In review question 3.5, number 1, it says, which best describes an elastic collision? An elastic collision has conserved total energy, conserved momentum, and conserved kinetic energy. This is the difference right here. It's the kinetic energy. Because in any collision, momentum is conserved and total energy is conserved, but not so for kinetic energy. We have a 50-gram golf ball in question number 2 thrown upward with an initial velocity of 12 meters per second. Assume that the initial potential energy is 0. Find the potential energy, kinetic energy, and total energy at each of the following. Initially, it has no potential energy because it is that point that we determined to be 0. So the kinetic energy is equal to 1/2 mv squared, or in this case 3.6 joules. Just plug their numbers in. At the point 2.75 meters above the initial position, for part B here, potential energy is equal to m, the change is 2.75, and h, that's just a sec here. It's mass times g. I forgot g. 9.8. So for this one we get 1.35 joules. The easiest way to figure out the other one is to simply subtract it from the 3.6 because it has to be conserved. So kinetic energy is equal to 3.6 minus 1.35, or 2.25 joules. The total is equal to the initial kinetic energy, 3.6 joules. And it's that 3.6 joules that will make our math easier, because we remember that it's conserved in the reaction, or in this transformation. So at the maximum height, the ball reaches a maximum potential energy. So potential energy will equal 3.6 joules at the top, and the kinetic energy will be equal to 0, but the total energy will still be equal to 3.6. So the total energy does not change. It is always 3.6.